Welcome to NASA's Summer of Innovation Lesson Support videos. I'm Steve Cullivan, NASA Aerospace Education Specialist at the John C. Stennis Space Center in Mississippi. This lesson support video is Failure, an Engineering Concept and Learning Tool. A difficult challenge when we teach engineering is dealing with the concept of failure. For some students, not getting something right or not having something work the first time is a monumental learning obstacle. Educators often ask us how they can work with the concept of failure in the classroom so that students have the tools to try something difficult and stay with it until they find a solution. Students should realize that failure is an engineering concept and part of the engineering design process. Since we have had so many questions about this concept, this video has a few ideas of how some of us teach this concept and includes some support resources from NASA. These can help students understand the skills and process it takes to work through frustrating moments. Today, we will look at what failure is in the engineering world and how we can successfully implement difficult lessons with some teaching tips and tools. Finally, we hope that along the way, we provide some great NASA connections for you to share with your students. A good place to start is to have students define what failure is. What do they think of when they hear this word? You might ask students to write down words on the chalkboard, write journal entries, or draw pictures. Failure is a word that can strike fear into the mellowest of students. I have shown the egg here as an example. Since most of us can relate to the idea of not cracking the egg just right or watching it slip out of our hand and fall onto the floor. If we go back to the egg idea, did we crack it wrong? If we dropped it, did the shell fail at that level of impact? These questions can start to take us to an engineer's point of view about failure. On this slide is a quote by Henry Petroski that can help us picture the integral role failure plays in engineering. Quote, "An idea that unifies all of engineering is the concept of failure. From the smallest paperclip to the finest pencil leads to the smoothest operating zippers, inventions are successful only to the extent that their creators properly anticipate how a device can fail to perform as intended." Unquote. This quote helps us to see through an engineer's eyes. Now, with this engineering perspective, we can realize that Petroski's next comment, that all inventions by engineers have failure calculations, gives us new insight into the egg. The egg might be expected to stay intact in its carrier, but not if we drop it on the way to the frying pan without any protection. Failure can be expected then. The egg just doesn't have the materials to handle ceramic tile at a high impact speed. So what do eggs, failure, and NASA have in common? To start a great lesson plan, teachers here are learning to teach the Mars Pathfinder Egg Drop Challenge. The goal is to create a landing system that will keep your egg from breaking as it hits the floor. It's a great lesson to start with, and you can find it in the Summer of Innovation Engineering Design section. Hoping that you are inspired to teach it or another engineering design lesson, we will now move into our teaching tips. I'd like to share 6 teaching tips next. We will give an example of each one in the following slides. At NASA, teamwork is critical. Learning to work together and live together in small spaces can be a critical part of the job description. Here you see 2 support divers assisting an astronaut as they practice for an EVA, or extravehicular activity, otherwise known as a spacewalk. Working with your students to develop teams will be an essential ingredient in your success. A great way to focus on this idea in the classroom is to try some team building activities. You might also want to visit the NASA Digital Learning Network to learn about how the astronauts train in the module Humans in Space. Don't forget the engineering design process as you undertake this challenge. If you need a quick overview, we have done just that in the design process video. It really helps, especially when the egg ends up looking like the one we saw earlier. You can use this diagram to display in the classroom. It can provide a great framework for asking questions when students get stuck. Don't forget to celebrate the success in the process. Building the space shuttle was not easy. A successful mission is great cause to celebrate and can be a great classroom poster. But there was a long pathway to achieving the difficult. The design process was used, then used again, and again many times. When you're working to teach students about failure and the process, it helps to have photos of great moments and the process it took to get there. Sometimes our words prevent us from going forward. This is too hard. I failed. I can't do this. No one has solved it yet, so they won't. Then you get into a negative loop. Here are some of the phrases I have heard over the years that help students get out of that negative loop or tackle a problem. The key thing here is modeling that positive questioning, problem-solving stance. Sometimes keeping certain phrases in the room or using them in class helps students choose these phrases over utterances of total frustration. For ideas to be nurtured, students need to feel safe about taking risks, know when to support each other, be willing to accept challenges, and get to be in a learning environment that values questions and doesn't always provide the answer. Creating idea boards where ideas can just be, with no editing, can help get ideas flowing. Encouraging students to keep idea journals can help them see that their ideas change over time. Another thought to keep in mind is deciding if it is of value for the students to compete, or will that shut down the learning and listening process. This quote is well known and inspirational at NASA. It is about choosing the difficult and then doing the work to get it there. Next, I would like to share some examples from NASA where the concept of failure, as an engineering term, played out with the fear of failing and the design process overcame. We have taken the first steps. The difficult was achieved, and this footprint still remains on the moon. But what other difficult projects has NASA taken on? Sending rovers to Mars has been a difficult task. You can share the history of the Mars missions with your students through NASA's Digital Learning Network and their program, Mission to Mars Expedition. Your students will be fascinated to see engineers tackle the difficult mission of designing a spacecraft that could get to Mars, survive the descent into the Martian atmosphere, land without braking, and then deploy a remote-controlled robot. I hope this photo of the airbags that were designed to protect the rovers and would later bounce over 8 stories when landing on Mars catch your students' attention and encourage you to learn more about the wonderful story behind the arrival of Spirit and Opportunity on Mars. If curiosity got the best of you, pun intended, you can go to the JPL website and follow the launch of the new rover Curiosity heading to Mars in fall of 2011. Don't forget to take the challenge and design your own extra great landing system in the Mars Pathfinder Egg Drop Challenge lesson plan. Thank you for joining us as we explore together in NASA's Summer of Innovation. And special thanks to the many education specialists and the NASA Digital Learning Network who helped make this video lesson possible.